In this video, let's add a procedural forest to our landscape. We'll add some filtering so that trees don't spawn on steep slopes and trees thin out as we get higher up the mountain. Alright, so we're going to start from scratch. So to create a procedural forest, we will first need the Procedural Generation Framework plugin. To enable it, go to Edit, Plugins, and search for PCG Content Generation Framework. We will also want the Procedural Content Generation Framework Geometry Script Interrupt. Then we will want to enable the Procedural Vegetation Editor plugin. If these plugins aren't already enabled, you will be prompted to restart Unreal for them to take effect. Go ahead and do that now. Now that we're back, let's drag a PCG volume into our landscape. It's a little small, so let's make it scale 10. The volume defines where our PC generation will occur. The actual generation behavior will be defined in a separate PCG graph, which is assigned to the volume on the PCG component. To create a PCG graph, open the context menu, right-click, PCG, then PCG graph. We will be creating our graph from scratch, so select Create Empty Graph at the bottom of the pop-up. I'm going to name ours PCG Forest Graph. Then if we go back to the details panel of our volume, we can set the graph to the one we just created. Now let's open up PCG Forest Graph, and we will start with a super simple graph. Don't worry about the input and output nodes. We won't be using them for our forest. Right-click and add a Get Landscape Data node. Then drag off the output and add a Surface Sampler node. With the Surface Sampler node selected, press D to debug it. You can also right-click and select the debug option. This makes the output of the node visible in our scene. Now if we go back to our scene, the Surface Sampler should be visible, but we don't see anything. If you have been following along with the previous tutorials, we are using level streaming and HLODs. In the outliner, if we make the HLOD textures hidden, we will see our landscape isn't actually loaded. This is an easy fix. Go to the landscape in our outliner, select all the streaming proxies, right-click, and force load. Now that we have a landscape to pull data from, select the PCG volume and press the Generate button. Nice, now we are seeing our Surface Sampler points. We call them points, but really they are boxes. By default, the Surface Sampler places the points with some randomness. So let's quickly discuss what the colors of the blocks mean. That is their density value. The density value ranges from 0 to 1, with 0 being black and 1 being white. If we click on the Surface Sampler, we have some basic settings we can play with. The points per square meter controls the density or number of points. Point extents controls how big each point box is. For now, we can leave it at 50. Looseness controls how closely spawning follows a grid pattern with a range of 0 to 1. If we set looseness to 0, it follows a grid. The unbounded option makes the sampling extend beyond the limits of our volume. Let's keep that false for now. The seed is used to provide randomness to our generation. If we change it, we see that points spawn in different places and their density values change. Let's try out using the density values. In the PCG graph, drag off the Surface Sampler and search for Density Filter. If we look at the node settings, it has a lower and upper bound of 0.5 and 1, so any points with a density value less than 0.5 will be removed. Now to see the results, we need to stop debugging the Surface Sampler node by selecting it and pressing D, and then selecting the Density Filter and pressing D. Then we will see that as we adjust the filter, nodes go away and come back. So I think we are ready to stop looking at cubes and start spawning trees. So let's go to Fab and get a Mega Plant tree. In the context menu, go to Fab and search for Mega Plant. Click on the tag Quixel Mega Plants on one of the results and it should take you to the Mega Plant page. There are quite a few options. For our demo, let's grab the English Oak and press Add to Project. This is going to take a while to download, so let's skip forward in time. Alright, it's downloaded. Back in our graph, drag off the density filter and select Static Mesh Spawner. Then under Mesh Entities, add an array element, open up its descriptor, and search for oak. You will notice that there are no full trees available, just branches. That is expected with megaplants. Quixel megaplants are the starting point for generating new skeletal and static meshes using the Procedural Vegetation Editor. To generate the static mesh, we need to create a Procedural Vegetation object. This is more simple than it sounds. Right-click the context menu, go to Foliage, then select Procedural Vegetation. Nice. We don't need a template, so select Create New Procedural Vegetation. Let's name it PCV_ for Procedural Vegetation English Oak and open it. Now we have a blank graph. The download from Fab for the tree included presets to use with our graph. So right-click and search for Procedural Vegetation Preset Loader. Then we'll set the preset to PVE English Oak. It has 4 outputs, which are the 4 variations of the tree we saw in Fab. So for a minimal graph, let's drag off the first output and add a mesh builder node. So now we built the mesh. Then let's add a foliage distributor node, and this will set the leaves. This node might take a while to build. Then we'll add an output node. And we can set where our output will be saved, and we can name it. So let's name it SM_ for static mesh English Oak A. Then set its type to static mesh and keep nanite foliage true. There are lots of other fun customization nodes you can use, like gravity. For example, we could increase gravity to make our tree slouch. Anyway, let's duplicate the nodes for the other 3 variations of the tree and set up their outputs. So now we have our 4 named main trees. Just as a note, you can mess with more settings in the foliage distributor to change how leaves appear on the tree, and if they look healthy, or their orientation, or how their buds form. You could even add foliage from other trees if you want. Let's just use the defaults for now and export our trees by pressing the export button on the top left. This takes a while, so we're going to skip forward. Now that it's exported, let's go back to our graph and use our generated static meshes. We'll start with English Oak A. Going back to the viewport, we can see our trees. If you are seeing big gray cubes, you probably still have debugging enabled somewhere on your graph. Here's an example of this happening if I turn debugging on the static mesh spawner node. Next, let's make our volume scale a bit bigger and move it to a more sloped area. This exposes a couple things we should fix. First off, the trees are following the landscape normals. They should be generally growing straight up, regardless of the slope. To fix that, let's go back to our graph, and before the static mesh spawner, add a transform points node. Let's pop out our window so that we can see our viewport in our graph. Then let's set the absolute rotation to true so that we ignore the landscape normals. And there you go, our trees are pointing straight up. Now if we zoom into the bottoms of our trees, we see that they are sitting on top of the landscape, which looks really fake. So let's fix that by updating the offset minimum along the z-axis to -50. We also want the trees to have random rotation, so let's set the rotation maximum along the z-axis to 360 degrees. Let's also mess with the scale mins and maxes so there's some variation in how big each tree is. Even though these are all the same mesh, it's starting to look more natural. Now let's make the volume scale 100 and move the mesh to an even more intensely sloped area. Let's go back to our graph and highlight the transform and static mesh spawner nodes and hit E to disable them, and let's debug the density filter to see the points more clearly. The points spawning do not care about the slope of the landscape, so to remove the points that are on the steep slopes, we will assign density values based on the slope and then use a density filter. To do that, go back to our graph, drag off the first density filter, and search for normal to density node. This assigns a density value to each point based on how similar the point's normal is to a straight up vector. White equals more similar, and black equals less similar. In other words, white equals more flat, and black equals more sloped. If we go back to the scene, we can already see the points on slopes are slightly grayer, but we can make this more noticeable. Let's drag off the normal to density node and add a pow node for power. In this node, we will multiply the density values by themselves to make the contrast more noticeable. To specify that we are changing the density value in the pow node, go to its settings and press the plus button next to input 1, then go to point and then select density. Let's debug just the pow node and set the second input to 2. Now if we up power value to something like 8, the difference is more noticeable. The power node is really just needed for visualization, but it isn't hurting anything, so we'll leave it. Let's drag off it and add a density filter. Debugging it with a lower bound of 0.5 already looks to be filtering out slopes pretty well. If we turn the power nodes debugging on and off, we can see the nodes that got removed. Let's re-enable the transform and static mesh spawner nodes. Sometimes reconnecting these nodes acts finicky and doesn't want to take your results. If you're getting weird results, make sure no connections are hidden or overlapping each other in your graph. And if that doesn't work, you can press the cleanup and then generate button on the PCG volume in your scene. If that doesn't work, try cutting and pasting the static mesh spawner node. That seems to help force the graph to regenerate. Nice, that looks pretty good. We don't have trees on our slopes. So let's make the volume even bigger and move it so that there are trees on the top of the mountain. Now to make things more realistic, we want the trees to be more sparse as we get higher up. To do that, we will use the height of the points to set their density value and then filter on that density. Let's go into our graph, disable the static mesh spawner with E, and debug the last node before it. Then let's go to the top of our mountain and get the approximate highest point. If we drag a cube into the scene, we can see that the highest point is about 39,000. Then if we go all the way down to the bottom and place a cube, we see that the lowest point is around 3,000. So that's the range of our height. We want to map the height range of 3,000 to 39,000 to the density values of 0 to 1. To do that, let's go back to our graph and add an attribute remap node. We will set its input source to points, position, and then we can add a .z to the end of the position to only get the z value. Then, on our range, we'll set the min to be 3,000 and the max to be 39,000. And on our output range, we'll keep it at 0 and 1. Finally, for our output target, let's set it to point density. Now if we debug the attribute mapping, we will see that the bottom points are black, and at the top of the mountain, the points are white. Now we don't want a solid straight line where trees start and stop based on height, so we want to add a gradient with some noise. To do that, drag off the attribute remap and add a density noise node. Set its mode to add, and let's try a noise min and max of negative 0.5 and 0.5. So now we have some gradient where the bottom of the mountain tends to be more black and the top of the mountain tends to be more white. Next, let's drag off the noise node and add another density filter. Let's set its lower bound to 0 and play around with the upper bound. The higher the upper bound, the more cubes appear higher up on the mountain. Let's re-enable our static mesh to see this more clearly. Again, sometimes I have to cut and paste a node to make the graph update. Anyway, now we can see less trees on top, and as we get lower, there are more trees. Now let's add some variety to our forest by adding the other static meshes we generated to our mesh entries. I'm going to also add the birch trees from the intro. The mesh entities don't even have to be trees. You could add rocks or sticks or whatever you want. Now if we walk around, the trees are starting to feel not so samey. This tutorial is getting pretty long, so next week, let's expand our forest and make it bigger, and we'll add some undergrowth, rocks, and dead branches. We'll also add a river that cuts through the procedural forest and maybe some wind effects that make the trees seem more alive. Thanks for watching. Subscribe to continue learning. Thanks. Bye.